Okay, so we'll finish up the discussion by making the pod connect to an I-beam, which we've already pulled in, but I want to go through that process again. So on the sketches, let's see which one. Where is my screen? So I'm still in the manufacturing module from last time. Okay, so that one looks okay. Now we have the timeline and the sketch. So let's hide the ID for the 3D printer, and I want to suppress the scale. And by suppressing the feature, it goes back up to full size. I can still shrink it down if I decide I made changes or I wanted to refine the connection, but uh, scaling down the connection is going to be really small geometry, so probably not going to utilize that. So let's go into a sketch and we'll find some place to add a rectangle, and we'll make it 1 millimeter by 0.25 or 1 meter by 0.25, and then enter. And let's see, there's the origin. So if I were to go L on the keyboard and X on the keyboard, I would be able to find the midpoint, and then I would want to make that vertical. All right, so I'm going to probably end up modifying the position. So my geometry, there's my sketch dimension D. So that's showing 0.8, let's just go 0.9, and we'll finish the sketch. Go into the extrude, the region selected. I want it to be symmetric, and the whole length with a distance, let's go back to 0.25. And it's not going to be a cut, it's going to be a join. And join is going to add that to the mix. All right, so I'm in the orbit. Now I have a contact patch that I can go into my next new design. All right, so this is going to be treated as either a bottom-up or a import of the I-beam or whatever we're going to end up with as a rail. So I want to insert the McMaster components, and we'll go to an H-beam. And I'm just going to find the largest H-beam for our representation. We're going to bring it in as, well, if it will expand out. Oh, I need to tell it what the length is, so 6 foot, and then I want to bring it in as a step file. Okay, and once we download it, it's going to update the geometry. Okay, there it goes. All right, so it's not exactly in the position that I want it in, so I'm going to be able to rotate it 90 degrees and then rotate it 90 degrees. All right, so we'll make this the component assembly since it brought it in as a component. It's not an individual piece that we're working with. I'm going to expand out the data panel again, and I'm going to bring in the pod. All right, so, well, that's an interesting direction. So since, let's go 90 degrees, we'll drag it down a little bit so that I can see my geometry, rotate it into position, and close enough. We'll hit OK. All right, so the 6 degrees of freedom, Let's see if I still have this one up. So using one of the PowerPoints, 6 degrees of freedom, we have X, Y, Z, and we can move back and forth, translate through each of those three axes. And then we also have rotation that we need to control. In SolidWorks and NX and Inventor, you are adding constraints one at a time or multiples to constrain those 6 degrees of freedom. In Fusion, the joint function, okay, going to the assemble and into the joint, constrains all 6, and then you tell it which ones to remove so that you have motion. All right, so this face, we have the centroid of the face, we have each of the points around the outside. So I would like to go the centroid of that face, and I'll just use the cube, and we'll go to the centroid of that face. And then back into our home or isometric, and now I can tell it what motion I would like to have. We have rigid, revolute is going to be revolve or rotate. We're going to be doing a slider, cylindrical, probably around the axis, pin, slot so that it's constrained, staying in the plane. All right, so it's showing me the preview. It's not a z-axis, and it does look like the x-axis. Let's take a look at the y-axis real quick. And custom would be like a combination of more than one. All right, so the minimum and the maximums, let's see, we're still in our motion, and we're going to go 120, so 10 feet or what's that, about 4 meters, 3 meters. All right, so we can see this move forward 120, and I didn't get it set, but we have a reasonable representation of what we could see as the motion and possibly put this into the animation. The render, if we applied a material or did something to the faces, we would be able to pull that geometry. So I'm going to save this as my pod assembly or my mag assembly. And we'll close that out. And the last thing I would like to do to the pod is to create a shell, because we left this as a solid for the ease of 3D printing it. The shell then is going to allow it to be opened up. So if we go that way, go into the orbit, oh, I'm still in the command. So let's just rotate over, and 0.1, probably pretty thick, and going to the inside. Oh, might have locked it up here. Okay, it got up. Put the 0.01 in, and it's still got the selections. Shell cannot be created at that thickness. Let's see, we're doing sharps. I'll see if it goes to the rounded. Still not liking the result. All right, so it had to calculate and then figure out what it was doing. So let's go back in as soon as it releases it again. And we'll go back to the home position. And now we have something that is hollow on the inside, and we could start building frames and other geometry around. On our view, let's see, on the inspect, we have section analysis, and this is going to create an analysis folder for us. So as I drag this through and see what it's doing on the interior, wherever I pick from, then we'll go ahead and hit OK. So when I'm through doing the analysis, then I would come back over hide and have it return to the full shell. So this is an iterative process. We're going to go through on a complete project, and we would build several concepts. We still have to have a way to make the doors operate, getting the electricity to everything. This is very preliminary concept stage to start our project.